All right, hello, my wonderful students. This is foldable number 1 for section 2.7, solving by substitution. All right, for our first problem, we have this one here. Let's go ahead and zoom in a little bit. We have 3x plus 4y equal to 12, and 2x plus y is equal to 10. So this is our first set of equations. So what we're going to do first, get a color, let's use blue. It's going to be our step 1. Step 1. And our step 1 is going to be solve one equation. All right, so I'm going to choose the second equation to solve because the y is already by itself, so it makes it easier to do. So let's just go ahead and put our 2x plus y equal to 10. So in order to solve, because you only have to solve for one of the variables. Oh, okay, I should put that here. Solve one equation for one variable. And we're actually solving for the y in this case. So we're going to subtract 2x to both sides here. And this subtracts to 0, leaving us with y is equal to negative 2x plus 10. Because this is at plus 10 there. All right, now that we have that done, we're going to go ahead and do our step 2. Step 2. And our step 2 is going to be substitute what is it called? The expression for y, or substitute what y equals. Substitute what y equals into the equation. So now we're doing into the first equation here. Oop, hold on a second. There we go. So now we're going to substitute y equals into the equation. So we're going to use the other equation. So we used this one already to do our solving for the step 1. So we're going to go ahead and substitute it here. So we have 3x plus 4. But we're not going to write y because we already know what y is. We're going to substitute that in. So negative 2x plus 10. And it's going to set that equal to 12. All right, so now we're going to go ahead and do our distribution. So our 3x comes down. Then we have 4 times our negative 2, which is negative 8x. Then we do our 4 times our 10, which is plus 40. And this is all still going to be equal to 12. All right, so now we're going to combine like terms, and we're going to subtract the 40 at the same time. So we're going to minus 40 to both sides. And we're also going to combine like terms. And this is going to give us our negative 5x is equal to, let's see, there's a calculator. Boop, 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 boop. And that gives us a negative 28. Yep, all right. So now what we're going to do is we're going to divide both sides by negative 5. And I know we're going to get a decimal. This one ends up being, let's see, I think that's, so x is equal to 5.6. So that's our x. So I know we technically already had our y, but we didn't actually solve for what our y value was. We just knew what this was here. So we're going to go ahead and substitute this back into the original equation. So step 3, which we're doing black, is going to be substitute the x value back to the original problem. And that's the one that we ended up, solving for the y. So we're going to substitute in here. So we have 2 times 5.6 plus y equals 10. Well, 2 times 5.6 is 11.2 plus y equals 10. So we're going to go ahead and subtract 11.2 to both sides. And we get y is equal to negative 1.2. All right. Just like for anything, we need to check. So let's go ahead and check to see if this is true. Okay, so we're going to go ahead and plug that back into the original equation again here, this top one. So we have our 3 times our 5.6 plus our 4 times our negative 1.2, and we're going to say this is equal to 12. Okay, well, 3 times 5.6 is actually 16.8 plus, plus 4 times negative 1.2 will give us a negative 4.8. So the 0.8, this is going to be subtraction. So if I did 16.8 minus 4.8, this would equal our 12, which is true. True. So now we have our, therefore, and our point is xy, which in this case was 5.6, comma, what was our y again? There we go, negative 1.2 is the solution. Okay,